Bagidalia. I am the Senior Director of Digital Economy, Technology and Innovation with the Canadian Chamber of Commerce, and I will be moderating today's webinar. So welcome everybody, and again, thanks for joining us. So I give you now a brief overview on today's webinar to set the tone for the session, and then I let the speakers introduce themselves and their companies in a little more detail. So you may be surprised, or perhaps not, that fewer than 1 in 10 businesses are actually ready for artificial intelligence adoption. And despite all of the AI hype, so artificial intelligence hype, that we read and hear about, and actually already for quite a few years, the reality remains that a vast majority of companies simply do not have the capacity to augment their business operations with AI at scale. So that often results in a series of one-off projects and sometimes pilot projects per se. So while AI adoption may have its obstacles, from understanding how to benefit from cutting-edge AI research to tackling sticky governance issues or upskilling employees, a comprehensive plan of attack, as we may call it, can help your business achieve its long-term AI objectives and goals. So before we go into the presentations, I would like to introduce the wonderful speakers we are honored to join by today. Let me start off with Nicolas Chapadot, who is the co-founder and chief scientific officer at Element AI. There you go. Secondly, Ziad Touzani of Data Performers. He is the head of partnerships. And thirdly, it is Stéphane Boivin of Pivot 88, who is based in Hong Kong, as I had noted, and we will listen to his pre-recording at the end of the presentation. So without much further ado, Ziad, I understand that you'll be the first to present, so the floor is yours, and thank you very much in advance for sharing your insights.
Thank you everyone for attending this webinar, and also thanks for the Canadian Chamber of Commerce for making that possible, this journey into AI. So first thing, I would like to start by presenting Data Performance, like a small introduction about us. We are an applied AI company based in Montreal. We are really strong in operationalizing AI, and some of what's really defined us is that our client really own his AI model. We are not asking rights for that. And also I would say the fact that we have a really diverse team from different backgrounds help a lot in trying to solve our client problem and also find the best AI way to solve it. So currently we have 4 products. Ask, which is an AI deployment platform. Like if you have an AI model, Ask is a way to make it operational. Space Neuron, which is really specialized in flight dynamics prediction. Macula AI, our last product, it's a visual inspection, deep learning based product. It is used mainly in manufacturing lines for detecting defect and for quality control. And VidAI, which is an COVID-related solution for social distancing. So during this webinar, you will hear about one of our clients, Pivot 88. This use case will be really, I think, helpful for everyone to see what we can do with AI and how much AI can bring to people and to companies. So let's start this, I would say, introduction to AI. For that, I will try to answer 3, simple questions. First of all, what is artificial intelligence? What's machine learning and deep learning? We hear a lot of these words like in the last years. And why we speak about AI now? So let's start with what's AI, or maybe what's not AI. For lots of people, when they think about AI, they really think about movies like 2001 Space Odyssey, or for like maybe younger people, the iRobot. So what they have in common is they speak about artificial intelligence, but AI is always depicted as an evil AI. But more than that, it's really science fiction. Like, what I would like to do with this introduction is really to drop the fiction and keep to the science of what's AI. There is really different kind of definition for artificial intelligence. The one I choose is from Cédric Villani, which is a French mathematician. For him, artificial intelligence is that ambitious objective to understand and reproduce human cognition, or, in other way, creating cognitive processes comparable to those found in human beings. So that definition is, you will find it may be quite general and quite broad and maybe so much clear, but it's really that for now, like what we really is AI. It's a field that is not yet, it's something we didn't reach yet because maybe we don't know how to define intelligence first. Like maybe if one day we can really have a clear definition of what's intelligent, we'll be able to reproduce that. But for now, it's really something we are trying to reach an objective or an ideal. And to do that, we are trying to use different ways. And one of the ways that was first used in the 60s and 70s was what we called expert system. So that way to reach this intelligence was really based on logic and human and deductive reasoning. For instance, like the kind of thing that it tried to reproduce is like when you have a sentence where you have element one and element two or element three reach to that conclusion. It's really some kind of syntax that we try to reproduce, or maybe if A implies B and B implies C, then A implies C. So we tried really to reproduce that, and it was quite successful, and it had really amazing results also for at that time. One concrete example that we see still today, but that is so much embedded in the application that we no more are aware of that, is really like in your editing application, when you see like the editor underlying in red some words or in other colors, is really what expert system is. Like it's really trying to find some rules to match them in order to highlight some problem that he can find. So expert system, like as I said, had some limits also. One of the big limits is that it needs an expert to write all those rules for which the system will work with. And that brings some limitation because some problems are so complicated that you cannot just tackle them with some list of rules. And progressively that led to the industry just abandoning this AI approach for intelligence. Meanwhile, another, I will say, approach or way to reach this intelligence was developing. It's the machine learning. So machine learning is a field of study that gives computer the ability to learn without being explicitly programmed. So this definition is from 1959, and you can see that it's quite old. And I will explain also why we speak so much about machine learning now in answering my last question. So machine learning is that approach to intelligence where rather than trying to explicitly program, like putting lots of lines with if, else, for loop, and so on, we rather try to let the computer learn by itself. And how the computer will learn by itself is really like by bringing him lots of examples to learn from. And those examples are typically data. So you can wonder how we can teach a computer to learn. We have actually different approach to do that. One of them is what we call supervised learning. So supervised learning is really like when you take an input and you try to reach an output. Like you really try to find this function or that will map the input to the output. So it's really what supervising learning do. One example, we were working at Data Performance is a project with the World Anti-Doping Agency. We had lots of data from the athlete, like the results of their test, and we know which athlete was doping and which one was not doping. And what we are trying to do is develop a model that will be able to find some like patterns or correlation on those data to be sure at really high accuracy when an athlete is doping and one is not doping. And typically what we do is we take data that the model never see and test it with the model and see how much the model will be like predicting the right results. The other approach for learning is what we call supervised learning. So the difference with the previous one is here you don't have a results. You have lots of data and you are trying to find some way to gather them together, to find some pattern. Typical application that we do generally is client segmentation. Like our clients have lots of data about their client, but they don't know how to gather them together. And unsupervised learning is really powerful technique to do that. The last approach for learning is what we call reinforcement learning. It's typically what you see in self-driving cars. Reinforcement learning is a way, like I would say, it's the policy of the stick and carrots. Like as much the model will behave like in a way that he will get a reward, he will improve, and the other way, like when he's not behaving and getting really bad score, he will understand that it's not typically thing he have to do. And for self-driving car, we can imagine that at the first beginning of that, like cars were maybe running into trees and they were getting really bad score, and they understood that it's not what they do. And while they keep in following the road lines, they get a really good reward, understanding that this is typically what we should do. So machine learning is really strong at that, like trying to tackle problem really complicated that even human cannot sometimes see all the steps. So now that we see what is machine learning, what's deep learning? Deep learning is a really hype word for something really, I will say, simple. Deep learning is really what we call a neural network. So a neural network is one of the several techniques that we have in order to support this machine learning approach. Like you have other techniques like probability and Bayesian techniques. You have also like what we call trees and so on. So neural network is one of those techniques that is structured in different layers. Each layer have neurons, and as I was explaining to you for supervised learning, for instance, here you have input, it's a face picture, and you have an output, which is the result, so maybe human or not human. And what a neural network will do is really typically for each layer, it will try to specialize in order to find, to reach that accuracy at the end of the process. So maybe for first layer here is just trying to understand what's the line in the picture. The second one is really to understand what's an eye and a mouth, and the last one is really patterns of faces. When we speak about deep learning, it's really here where we found the black box that you maybe heard a lot in the media. Like sometimes this neural network became so complicated that it's really hard to understand what's really happening inside. So we have techniques to more or less understand, but we'll never be able to understand 100% what is really happening inside. So deep learning is in fact a neural network with more than 3 layers. So it's really that what we say, what we call a deep learning. Deep learning is really strong for used in computer vision. Like when you have lots of images, it's really strong to catch, for instance, defects. It's a typical project we have run, and based on that, we developed a workload called Untitled AI. It's really it's trained with all the images of a client for detecting defects. And through that training, the application will be able to spot defects and highlight it to the user. Another way, or we can use deep learning, is really with cameras. Like for Vida AI, it's really an application to try to find which people are wearing masks and which people are not, and also find social distancing if it's respected or not. So to sum up, artificial intelligence is really like this ideal that we are trying to reach. Machine learning is really one approach to reach this intelligence, and deep learning is one technique based on neural network. So to answer my last question, why we speak so much about AI now, it's really because data have exploded in the last decades in volume, but also in diversity. Like when we think about data, we think also always about database, but it's not just that. It's images, as we saw, like sensor measurement, it's geographical coordinates. So it's all of that. And in the definition of machine learning, you saw that it dated from 1959. All those, I would say, algorithms were like known at that time, but we didn't have the way to prove them. And the amount of data needed to train the model to do that. So the computing power was also something that was lacking at that time. And with GPU specifically, we are really able to speed up the training of our model. And we have also now much more smarter algorithms that need less data to be trained. And also that, like one algorithm that I really like to speak is GAN, like generative adversarial network, which is like making two models compete against each other in order to improve. And finally, it's really the big investment that we saw recently by the GAFAM, like Google, Apple, Facebook, Amazon, Microsoft, and their Chinese counterpart, Baidu and Tencent, that are doing in artificial intelligence. So all of that is really triggering this AI moment we are really living now. So I hope that with this introduction, we'll have a really better idea about what is AI, machine learning, and deep learning. And so you'll be able to like spot in media what's not AI and what sometimes is really a hype and really, I would say, a science rather than science fiction. So thanks you everyone for your attention.
All right, thank you very much, Ziad. That was great for the insights, the overview, and I did like the summary at the end of the day because you presented on so many different areas, and to summarize it and bring it back to what AI is, what machine learning, deep learning, and why AI now. And from here onward, Nicolas, if you could continue and talk a little bit more about the journey of the adoption of AI. So the floor is yours, please. And thank you very much again, Ziad.
Yes, absolutely. Thank you, Ulrich. Thank you, Ziad. I'm going to share my screen now. Okay, so Ziad talked about the incredible developments that happened over the past few years in machine learning and more specifically deep learning. And these developments broadly give us a set of new capabilities that we can bring to bear. What is not obvious though is how do we take those new things that now machines can do and bring them to fruition and apply them in a way that they can have practical impact. And we call this journey the operationalization of AI. How do we make AI work for real in a business context? And so this is what I'm going to be talking about in the next few minutes. It is really about ways of thinking and ways of creating roadmaps, for example, so that AI can have the maximum impact in a business context. And the thesis for us is that AI really is the kind of glue that can make humans and machines work better together. We can have much smoother, much smarter interfaces that are mediated by AI advances such as computer vision, natural language processing, and other capabilities that enable humans and machine to much more closely collaborate on a task. The goal really is not for machines to take over and to replace human beings, but really to try to take advantage of the strengths of both in each playing a role towards reaching a certain business objective. It can be fulfilling a given workflow within a document processing context. It can be to do better quality control in a manufacturing environment. There are many, many different ways. And what we're going to be talking about is some of the thinking that can go behind using AI for such purposes. Maybe a quick few words about Element AI for people that would not be familiar with us. So the company is almost 4 years old now. We launched at the end of October 2016. We're over 300 people located in offices that include our Montreal headquarters, but also a presence in Toronto, London, Singapore, and Seoul, South Korea. The company CEO is JF Gagne, who is a serial entrepreneur that has a long experience in building enterprise software that incorporate advanced decision-making, operations research, and machine learning. And of course, we have as co-founder as well, Professor Yoshua Bengio, whom some of you may recognize as the co-father of deep learning. And he really pushed a very, very ambitious research agenda in this area at a time where it was not very popular from an academic perspective to pursue such ideas. And as luck has it, it has blossomed into the incredible successes that we have known today. And as a company, Element covers a number of different areas. I would say the main ones that we cover include end-to-end supply chain, so ranging from manufacturing, transportation, and logistics, and retail, as well as the broader financial services industry, including insurance, capital market, and banking. And the pharma that you see at the bottom, the angle we take is from a pharma manufacturing perspective. So, for example, quality control in the production of drugs. So the reason why AI operationalization is a pretty important topic today is that for a few years now, many forward-thinking and forward-looking companies have been trying to do AI use cases. They have been trying to figure out, okay, what does it mean to do AI? How can it impact my business? But as we have heard at last year's Web Summit, a very prominent CIO of a pretty large German company, the CIO was complaining, I have more pilots than Lufthansa. So in other words, there are many tests that are at various stages of development, but very few of them make it all the way to production. In fact, as some studies we have done and matching other inputs we see in the market, fewer than 1 in 10 businesses are actually successful in taking their pilots to have an impact in production. Why is that? So there are a number of different reasons. The first one is that as things stand today, experimentation with AI is often done in so-called innovation units or AI labs that are quite separate from the main business where they could be having an impact. And there really is a challenge in going from a prototype model and having it exit from the silo, if you will, and really reach production. A consequence of that is that since communication is so difficult between the AI labs and the business units, there is a lack of constant feedback between the business and the AI experimentation unit that would let the model stay up to date and remain applicable in practice. So that's problem number one. Problem number two is that AI solutions today are built a little bit as one-offs. They are built as very custom projects that do not benefit from the economies of scale that a more systematic factory-like environment, if you will, would make. It's quite hard to make a business case for how AI can deliver value. So there is no monitoring, there is no testing about whether AI is indeed making better decisions or indeed generating value in the different workflows that it can impact. And all of that together means that it's very hard to relate AI performance to actual business metrics, such as increased revenue or decreased costs. And so if we are going to embark on a journey to operationalize AI, it's very important to balance our steps in just the right way, to dance to the right tune. And what we say here is that it's important to plan for the next one and the next 100 steps. What do we mean by that? The next one step is really how we're going to be acting tactically, how we're going to be doing some exploration and finding some low-hanging fruits, if you will, that are relatively important use cases that can be done relatively simply from a technical perspective and that can demonstrate value for stakeholders in the business in a compelling way. And further down the road, we will want to be doing more experimentation with different types of AI models, trying them out at in different parts of the business. We will want to formalize our findings into a set of best practices, for example, that apply to our own company or an industry that we operate in. Then we will want to find ways to optimize those models. So either collect data better or create a more seamless interaction between the model output and the way that those predictions or decisions are used in practice. And finally, we will want to become more ambitious about how AI can transform the entire business. And this transformation really means usually taking bigger and bigger workflows in the organization and seeing, okay, which part of those workflows can best be done by a machine, which parts are best be done by a human, and which parts sit a little bit in the middle in a condition that we call a human in the loop scenario, where we have a very, very tight interaction between human and machine. And it's only when we reach this step, which is, you know, the 100th step down the road, that we can really talk about AI starting to transform the way a company operates. So to give to put things, you know, a little bit more concretely and tangibly, what this means, it means that an organization must perform continuous self-diagnosis. So it has to be quite proactive in identifying the different AI use cases, so the feasible and viable application of AI capabilities that lead to some kind of impact from the business standpoint. And the next stage is, after having, you know, done some kind of ideation session and having walked through the halls of multiple departments in a business, coming up with an organized roadmap of those use cases. So what is a roadmap? It is a prioritized sequence where we try to put the more impactful and feasible use cases first, and then tackle the more ambitious use cases a little bit later. And the important part is that the roadmap can also, the proper roadmap can help us set up the right kind of infrastructure within the business. Maybe we need to upgrade our data collection and storage capabilities, our data cleaning components, our computational infrastructure. So progressively, the roadmap, as it addresses bigger and more ambitious use cases, let us do the underlying work of putting in place the right infrastructure that will let an organization scale with bigger and more ambitious use cases. So one way in which we do this is that we use this famous four-quadrant matrix where we have feasibility on one axis and impact on the other axis. And of course, both of them are somewhat subjective, although they can be quantified. So for example, in terms of feasibility, we can rank the different use cases in terms of data availability, in terms of modeling complexity, in terms of whether we will be replacing a use case that is very, very mission critical in the organization, or if it's a more satellite process. So that's the feasibility axis. And in terms of impact, it really boils down to can we generate more revenue from tackling and solving this problem, or can we cut costs in some way? Can we reduce errors? Can we make humans more effective at the job that they do? So this process, of course, it's shown here in a banking context, obviously, but would be done through an exercise that involves upper and middle management in most organizations. So when this is done, we really see three ingredients to operationalizing AI. The three ingredients centers around the core capabilities of AI. The second consists in packaging those capabilities into reusable components. And finally, those components can be put together into solutions that solve, that address specific workflows in an organization. I'm going to briefly talk about each three of them. So on the capabilities front, this is where we have the closest interface to research from an AI standpoint. And many of you might know the amount of AI that's been going on, the amount of research that's been going on has just exploded in the past few years. We see on the upper right chart the study until 2017 of the growth, the relative growth in the number of papers between 1996 and 20 years later, 2017. And we have an 8-fold growth in the number of annual papers in AI specifically. And that has way overgrown the broader number of computer science papers and all papers in all scientific disciplines. So AI has really come of its own. It has exploded in the past couple of years. It's hard to keep up. And so this is why internally at Element, for example, we have developed strong internal research capabilities along areas that move very, very quickly, such as natural language processing, computer vision, low data machine learning, and so on and so forth. Having a cutting-edge model, though, is not quite enough, because if you want to have an impact in production, there are many, many more steps that need to be followed. The first one of them is making the individual components more robust and more reusable. So this is where we tackle traditional software engineering problems that relate to software development and software production. And that involves making sure that we have the right data to feed our model, that the labeling is clean, that we are very rigorous in how we do model benchmarking, training, model selection, and so on. And that once those models are put in production, we have the means to monitor them to make sure that the operational conditions do not deviate too much from the training conditions, and that, broadly speaking, the models keep performing and behaving as they were intended. And finally, when we put these things in production, we do it typically by bringing together a number of different components into full-blown solutions. And I give two examples on the slide. One is a use case that we are doing for insurance that we call Underwriting Partner, that is built on very general document intelligence capabilities that we have built. And document intelligence is a product that Element AI has that lets you take any document as input and extract fields of information from it, regardless of the format of the document. So it is smart enough to figure out that a name anywhere in the form probably means that you're trying to fill out the name for a customer, for example. And initially, you can bootstrap this with no training data at all, in which case the system operates in a kind of smart autocomplete mode with a very tight human-in-the-loop interaction. And as you give it examples of what certain fields mean on the form, it learns and it is able to make predictions and ultimately full automation of the recognition of a given document. So this is what we mean by a solution. It is the composition of natural language processing, optical character recognition, built on top of an explainability layer, all glued together by the right user experience. Same thing for another product that we have called Knowledge Scout that let us do natural language question answering capabilities, in our case in a manufacturing context, to try to document manufacturing deviations, for example, in highly regulated manufacturing environments such as aerospace and the pharma industry. The different concerns that need to be answered at the bottom right of the slides regarding the organizational maturity that need to be answered as questions. So on top of the traditional data availability and infrastructure availability, we need to make sure that in order to be effective AI practitioners, we have the right people that can both understand what AI can and cannot do at the management and leadership level, and at the more operational level, people with the right data science and machine learning backgrounds that can connect the dots in terms of applying state-of-the-art architectures and algorithms to the available data in the organization. That, of course, has to be surrounded by the right strategy that lets us plan ahead and will connect the different use cases that a company wants to tackle together so that there can be complementarity in the data that is put together, for example. And finally, a function that many companies often forget when they start to dabble in AI is the governance function. So just as about 10 years ago, 15 years ago, the big data movement brought to us the notion of data governance, meaning that we should be very careful about who are the data owners, who is accountable for the availability and the quality of data that goes into organizational or enterprise data warehouses. We see just as equally important the function of AI governance. So making sure that the models that are built and deployed satisfy basic robustness criteria, but also satisfy concerns such as making sure that the data sets are properly balanced so that the predictions that we make are not biased in favor of one subpopulation versus the other, for example, so that we can ask questions about the fairness and the ethics of the models, and ultimately whether the different types of AI being put in production are delivering value for the organization in a way that remains fair to all the stakeholders. And this is a last slide that summarizes a little bit the kind of chart that a company would fill out in order to increase AI maturity. So along the rows are all the different dimensions along which we would want to worry about stages of maturity, and the axes are where we are from a process of just exploring the first AI use cases all the way to having AI transform whole segments of the organization. And really, it is by filling out a matrix like this that organizations can become a lot more intentional in organizing their AI efforts and making sure it delivers value for them, but also all of their stakeholders. And with this, I will give it back to Ulrich, and we will be happy to take questions a little bit later.
Nicola, thank you very much for the journey to tech adoption in the AI field, and an overview, going a little deeper and then coming back with a summary, which actually leads us now to provide the overview that Pivot 88 will give us to explain how they adopted artificial intelligence in their business and specific sector. And my colleague Rebecca is so kind and will play that pre-recorded video for us. Rebecca, please go ahead, and thank you very much. Great.
Hello, my name is Stéphane Boivin, CEO of Pivot 88. I'm here today for the webinar that's going to be in a couple of weeks for the Canadian Chamber of Commerce on the journey of our journey at Pivot 88 of artificial intelligence. So before we start, just want to give you a bit of introduction before I get in the context of AI on what we do. First, we're a technology company based in Montreal with presence in Hong Kong, Vietnam, Bangladesh, and China. Today, I'm recording that in advance because I'm based in Hong Kong. Our software consists of two portions, the mobile device and the cloud portion. So in short, what we do, we help companies to give them visibility in their supply chain, most especially in their quality and compliance processes. So as soon as a company outsources or do some contract manufacturing, they lose that visibility, especially when you're manufacturing in places such as I just mentioned, Bangladesh, Vietnam, Turkey, across the world. So today, we have 18 different 18,000 factories connected across the world in 112 countries. So really, it's to digitize the process of quality and compliance. And again, why digitizing? It's really to drive, again, that transparency, but to give the decision maker the data they need to be able to make decision based on data that they can trust. So really, that's the vision of Pivot 88. So really, our solution, when you look at it, it's the before and after you see in factories, especially in Asia as an example. Digitizing the process starts really still done on paper, still done on PDF format. So really, by digitizing it, you're structuring it in different sections that you're able to give, again, that actionable data that the brands, in our case, in the case we're giving here in apparel, would have. So really, at the end of the day, it's connecting the supply chain partner in one platform and exchanging information at different steps of the way. So again, there you could have the factory and the brand on the other side. So really, the two portions, like I previously mentioned, the cloud portion that will be mostly used by the decision maker that are looking at the data, and then you have the multiple peers connecting. Again, the factory will use the mobile device to collect the different data and picture. Like you can imagine, we're collecting a lot of pictures when you're doing inspection and compliance at the factory level. So again, our solution quickly on that, when we mentioned earlier on, we're 360 quality and compliant software as a service platform. Again, when we're talking about transparency and visibility, it's starting very early on the compliance side here from the CSR. CSR meaning making sure that, as an example, that the factory is run properly. They're not hiring, as an example, having underage children in their factory, work in the factory. All the testing portion of the product that is tested before it starts manufacturing. So it's collecting all that data, and again, making sure that if there is some action or things to be corrected, that we're correcting it with correction action plan because of the non-conformity. Then on the quality side, well, we'll be focusing in the next few minutes on our initiative on AI, starting very early in the process from the raw material, when we're talking about incoming inspection, fabric in the case, the example we're giving today here, before a garment is produced, you have a roll of fabric, and then all the steps of the manufacturing in the line where the cutting, the sewing happen, end of line, final inspection, and again, when the product is shipped, either in North America or Europe or around the world, again, to validate that at the end of the day, we're validating quality and compliance, making sure it meets the norm of the brands that are basically giving those orders to the factories, in the case we're indicating Asia. So again, why did we have some AI initiative? Again, it was part of our product roadmap. The different people were requesting what we call intelligent quality. Again, right now the platform with no AI has obviously some workflow, some alert notification when thing goes wrong, but still needs a human intervention to be able to make a decision. One thing I always said is, when we created Pivot, it was to really remove that subjectivity factor from the process. So with the AI we've developed, we were able to achieve that. And let me introduce you our 4 agents. So again, we've Dolly, Molly, Polly, and Jolly are our 4 virtual agents. Again, each of them has a different tasks. So again, Dolly is helping what we call the QA manager, the quality assurance manager, to help better decision, basically to help them in making better decision process. As you can imagine, companies could make 100,000 and more inspection report in a year. So obviously, even if you have the perfect workflow and all that, you know, Dolly is helping the QA manager to flag if thing goes wrong, if there's an anomaly report, and we'll give the example on the picture in the next slide, but also the risk rating of an inspection based on the past information that is sitting on our platform. Because again, analyzing all those past inspection and coming up with a risk factor. Molly will sit on the inspector tablet. I'll be able to assist the people in the factory to be able to warn them from, again, the past information and to prescribe actionable item, like something in inspection is the AQL level, which is the acceptable quality level, to modify that based on past experience and to be able to have a more precise inspection because we know that something went wrong in the past. Polly and Jolly is mostly for the C-level executive that will generate, again, prescribed actionable data based, again, on the past information. Now you're talking about a higher risk level. Could be a country risk, not to source in a country, or a product risk, because if it's a new product. So again, Polly and Jolly, again, the difference between both, one will bring also outside data, like newsfeed, that's the case of Jolly, and again, we'll be able to analyze data of all of our clients able to give industry perspective based on product type. So again, this is high level of our agent. Again, on the report scanning, again, picture, like I mentioned earlier on, we're taking a lot of pictures, not us, but our clients are taking a lot of picture. So Dolly is able to associate, like you can see here, a picture taken, again, at site by the inspector. It's analyzed by Dolly when it's coming back to the platform. And again, based on image recognition, Dolly will basically say, based on past information, and again, pass on based on the information received, and it was the business rule written with the image scanning. It's, as the example here, it's there's a defect detected, so it's failing the inspection report. And again, you can see in the background also the risk factor I mentioned earlier on. Based on previous inspection, what is the risk of that inspection being wrong based on multi-tools? So the algorithm takes into consideration multiple things like the product type, the factory type, the factory that was basically did inspection in the past, the inspector, and so on and so forth. So all that algorithm is built in the background and will associate the risk, again, based on past information. So basically, so again, why we did that again, our client was requesting, again, that intelligent quality, again, to remove as most as we can the human factor in the decision-making project. So in conclusion, if I would basically say our lesson learned, obviously it's an IT project. So you need to calculate a buffer. There's always, obviously takes more time to deliver than expected. So that's still something we knew, but it's a lesson learned. And what I would also take it as a takeaway is it takes time, start early, and leverage people that have invested or have experience in AI. You'll definitely get the benefit from them. That's what we did here at Pivot 88. And that at the end you'll be out of the game. So that's my lesson learned, and again what I would recommend if we would to start that again. But definitely the journey is worthwhile. I would encourage anybody who's thinking about adding AI to definitely do it. And again, thank you for listening, and goodbye from Hong Kong. Thanks.
Thank you, Stefan, all the way to Hong Kong, and for this presentation. It brings us almost to the end of the session. However, I would like to look at all the questions that I have here in front of me and raise at least one of them. And let me see whether data performers or perhaps Element AI could speak to that. A question was raised, and maybe I hand it over to you, Nicolas, for now. Let me see, what are the two things that all companies interested in integrating AI into their operations must do to get started on their journey to employment? Perhaps you have any recommendation on these two must-do things for our listeners. Thank you, Nicolas.
Yes, absolutely, Ulrich. So it's easy to get blinded and excited by shiny new objects. And AI can feel a little bit like that, right? We have mandates from our board of directors. We have mandates from the top level executives to start doing AI, but what does it mean exactly? And the first thing I would suggest is start with the end in mind. So what are you trying to accomplish exactly? How is it done in the organization today? And really how AI could help with this goal that you have in mind to do a better job, reduce errors, make it more cost effective, and so on and so forth. So not take the technology per se and try to find, uses for the latest computer vision or the latest NLP model that would not be justified, but really start with the end in mind. And then the second thing is really look at all the prerequisites. The model capabilities are one thing, but we also need to flex the organizational capabilities in many, many other ways. The first of which is really data readiness and making sure that we have all the data pipelines that give us access to the right kind of historical data that can be used to train models, perhaps third-party data that can be used to complement and pre-train models according to some directions. And finally, that would let us put a given capability in production and monitor it. So those would be the two things I would start with.
Okay, great. Thanks for sharing. And you know what, Ziad, why don't I turn as well the floor one more time to you in terms of supply chain and also distribution channels. I have here a question. I have to just look around the corner to see it. I want to better understand artificial intelligence and its impact and opportunities in the distribution and supply channels. Perhaps a little summary and overview for us on that, if you don't mind.
Sure. So definitely for supply chain, there is I would say main problem that we can find always in supply chain. One of them is really stock management, like how to optimize your stock, because stocks are also like fixed costs for company and the immobilization. So typically AI can help a lot in doing a good prediction about how much you need and when. Other problem can rise really from the particular issue of each company, and this one also can be tackled by AI. I say we can also work on the quality by applying artificial intelligence. Yeah, I would say that's mainly the main thing we can do. I will add also that for supply chain companies that are interested to maybe develop a project related to supply chain, there is government, I will say, incentives that take up to 50% of the project cost. For that, it's through the initiative of Scale AI. So, yeah.
Thank you very much. So thank you, Ziad, Nicolas, and Stefan for today's presentation, for being here, sharing your insights and knowledge, and providing us on an overview on what is AI, machine learning, deep learning, as well as why AI now, and the entire journey of tech adoption when looking at artificial intelligence. So thank you very much, everybody. I hope we will see you again, all of you, the audience, and also panelists at one of our upcoming webinars. And as I had mentioned before, we will be sending you an email with a link to the recording in addition to Stefan's presentation, as there was an issue with the sound. Apologies again. Thank you for your patience, and you have a wonderful day. And thank you again for everybody's participation and for all the learning and insights shared. That was fantastic. I look forward to another artificial tech adoption seminar and bring it to the next level and learn more about it. So thank you very much again, everybody. Bye for now. Thanks.
Thank you. Bye-bye.